Hello everyone, in this video I will be showing us how to identify Brustoluric acid and base and their conjugates and a couple of examples on how to determine the pH and to know if a solution is basic, acidic or neutral. So this question says, identify Brustoluric acid and base and their conjugates in this equation given. So we know that brustoluric acid is a proton donor and brustoluric base is a proton acceptor. Brustoluric acid is a proton donor and brustoluric base is proton acceptor. So in this equation, we can see that hydrogen from H2SO4 has lost one hydrogen here, and it means that it is an acid, right? This is an acid. And it's lost an acid and it becomes this. So this ion here is going to be the conjugate base. This water here has accepted the proton that was donated from H2SO4 to become that. So it became the base and this becomes the conjugate acid. In the next example, we have this HNO3 and water. HNO3 lost hydrogen to become NO3. So it is a proton donor, right? And since it's a proton donor, it's going to be the acid. And this becomes the conjugate base. And in this case, water has gained the proton and is acting as a base here. And this is going to be the conjugate acid. So we have the acid here. It has lost an hydrogen, which is a proton, to become conjugate base. And this is the base that gains the proton, and here it becomes the conjugate acid. So for this place, we say the acid conjugate base pair. Acid conjugate base pair for this is going to be HNO3 and NO3 negative. So that is the acid conjugate base pair. And for this one, the base and conjugate acid pair is going to be H2O and H3O positive. All right. The next example says calculate the hydroxide ion concentration at 25 degrees and determine if it is basic or acidic or neutral. So what we do here is we use the dissociation constant for water. We want to start with this first. So Kw is concentration of OH hydroxide ion and the acid is going to be equal to 1 times 10 to the negative 14. We know the hydroxide hydrogen ion concentration to be that, so our hydroxide ion is going to be 1.0 times 10 to the negative 14 into our hydrogen ion concentration, which is going to be 1 times 10 to the negative 14 into divide by 7.5 times 10 to the negative 5. If you plug this into our calculator, it's going to give us 1.3 times 10 to negative 10. The next thing we want to determine is if this solution is actually basic or neutral. So our hydrogen ion concentration, we can see here, it's 7.5 into 10 to the power 5, and this is 10 to the power negative 10. So we can see that our hydrogen ion concentration is greater than our hydroxide ion concentration. So in that case, if that is true, what we have done, it shows that the solution is acidic because the hydrogen ion concentration is more than the hydroxide ion concentration. So for the second one, in which we have our hydrogen ion concentration to be 1.5 times 10 to negative 9, which is this one. So again, we're going to use the kW of water, which gives us our OH concentration to be 1.0 times 10 to negative 14 into 1.5 times 10 to negative 9. And when we plug this into calculator, it's going to give us 6.7 times 10 to negative 6. Again, we compare that. We're going to see that this and this one looks bigger. The hydroxide ion is bigger than the hydrogen ion concentration. We now say our hydrogen ion concentration is less than our hydroxide ion concentration. And if that is true, it means that our solution is basic. Right. The next one is we want to calculate the pH of hydroxide ion concentration, which is 1.3 times 10 to negative 2 molar at 25 degrees C. So the same thing will, for us to find the pH, we know that pH is negative log of hydrogen ion concentration. So we can find the hydrogen ion concentration from our kW, which is going to be 1 times 10 to negative 14 over our OH ion concentration, which is 1 times 10 to negative 14 over 1.3 times 10 to negative 2. And when we plug this into calculator, it's going to give us 7.7 times 10 into negative 13. So we plug that into our pH, which is going to be negative log of 7.7 times 10 to negative 13. And if you plug that into calculator, it's going to give us negative into negative 12.11. And that gives us 12.11. That is the pH. Right, the last one example I have here is calculate the hydrogen ion concentration for pH equals to that. So we know already our pH is negative log hydrogen ion concentration. And when we rearrange this, our hydrogen ion concentration is going to be 10 into negative pH. So when our pH is 4.8, so our hydrogen ion is going to be 10 into negative 4.8, and that is going to give us, when we plug that into the calculator, it should give us 1.6 times 10 to negative 5 molar. In the same way, when we have our pH to be 8.37, so the hydrogen ion concentration is going to be 10 into negative 8.37. And when we plug that into the calculator, it should give us 2.0 times 10 to negative 9. So this is how we solve problems on pH, OH, and POH respectively. I hope this helps. Thanks for watching.